So the next video here, we're going to look at the sphere. Sphere is something that we can do in 3 dimensions. Certainly calculate the volume of a sphere in past algebra classes or other math classes. One of the things we need in order to calculate that is the radius. And in 2 dimensions, we use the radius formula. That would be this part of RD here. So this first theorem 2.2 shows the distance formula, and what I've got highlighted in yellow there is the distance formula if we had just 2 dimensions, so an x component and a y component for 2 different points. So using the same theorem, Pythagorean theorem, to solve for this, it follows that we add the z component for the 3rd dimension, and that will give us the distance. All right, so down below, the equation of a sphere. The equation of a sphere should look very close to what the equation for a circle is. In fact, the equation for a circle is what I've got highlighted here in yellow. I guess ignoring that squared bit. Let's try again. So what I've got highlighted there is the equation for a circle. Again, a two-dimensional object in 2 dimensions there. So all we've added to this formula is our 3rd dimensional component, which is our z. Everything else that we're going to deal with is going to be the same. If you recall from algebra, the center of a circle, in this case, if we're looking at these, would just be simply A and B, and radius would be R. Now our center is going to be ABC, which you can see down here in our little graph. I'll scroll down a little bit for that. There you go. So that's our center there, and we go out as far as R. So how we're going to solve these these problems are going to be the exact same way you would have done it in an algebra class, or Calc 1 probably had them as well. So we're given this problem, find the equation of the sphere in standard form. Standard form is what we have there in the rule. We're given a fairly easy one to do. We're just going to actually use the form for it. So our center is at -1, 7, and 4, so our equation should be x minus a -1 squared plus y minus 7 squared plus z minus 4 squared, and that all equals 4 squared, which all we have to change here is this becomes x plus 1 quantity squared. And we can change this to 16. So this is what it would look like in standard form.